Now we're going to find ETA. I'm working problem number 5 on your ETA problems. It said at 9:16 your position is 37:10.9 north, longitude 75:29.6 west. You are turning 12.3 knots. What is your ETA at North Chesapeake Bay Entrance Buoy, NCA? I found my position. This is my latitude and longitude, my starting position. This is giving me my 9:16 position. And it says what time will it be when I get to NCA? This is one of those problems where you have a long distance to run, and the distance you want to run is longer than your parallel ruler. A good practice is open up your parallel ruler, and you can see this is actually a continuous line from the inside all the way down. So what I do is I take my parallel ruler, I line it on my 9:16 position, and I line it up on the buoy that I want. I draw a line, and this actually just helps me in plotting, walking a straight line. And what I did was I drew 2 points, or 2 lines, then I take my parallel ruler and I fill in the gaps. And you can actually just leave your parallel ruler there and walk your dividers down your parallel rulers, but I like to go ahead and take it from here. Now what I'm going to do is I'm going to open up, I'm going to find 37, and I'm going to open it up to 5, because I like working 5 miles increments, because your divider only goes up to about 8 miles. I'm going to point my point on my starting point, my 9:16 position, and every mark is going to be 5 miles. That's 5. That's 10. That's 15. And not quite a whole 5. So what I'm going to do now is I'm going to adjust my dividers from my last mark to the buoy NCA. And I'm going to come back in here, and that's 4.6. So that last mark was 4.6. Labeling is important. So I have 5. Next mark was 10, 15, and 4.6. So 15 plus 4.6 is 19.6. So I'm going to go down. I got to do my math. All right, now I have my distance is 19.6. So I'm going to go ahead and do my D, speed, and times. My distance is 19.6 miles. Zoom in a little bit more. 19.6 miles, and my speed is 12.3. It's given to me in the problem. Now I'm looking for my time. So remember time, anything above this line you're going to divide. So I take time equals distance divided by speed. So what I'm going to do is I'm going to take 19.6 and I'm going to divide it by 12.3 equals, and I get 1.59, and it's 3. So with it being 3, I'm not going to round up. I'm going to keep it 1.59. Now the problem is the minutes. I can't take minutes. It's 0.59 actually, so it's not minutes. So I have to take that 59, that decimal 0.59, and turn it into minutes. So what I'm going to do is I'm going to take my 1 hour, and I'm going to go up here and put it in the problem. And 0.59 of an hour, so I'm going to go ahead and take 0.59. Remember, in order to turn a decimal into time, you multiply it by 60. If I had a time and wanted to turn it into a decimal, I would divide. So in this case here, I'm trying to turn this decimal into time. So what I'm going to do is I'm going to go ahead and take 0.59 times 60 equals, it's 35 minutes. It's 35.4, no sense in rounding up. So I'm going to take 35 minutes. So that's how long it's going to take me to run from my position to NCA. So what I'm going to do now is I'm going to take 1 hour and 35 minutes and add it to my starting time of 9:16. 6 and 5 is 11. 3, 4, 5. Now see, it's 51, so it's less than 60, so I can just go ahead and 9 plus 1 is 10. So I have 10:51. Now, remember, if I'd have added this up and this had been 61, I would have had to take an hour and move my hour over here. But in this case, it's less. So I have an answer of 10:51. I look at the answer, they have 10:54. That's going to be the correct answer. Now realize I'm standing up, we're kind of doing this on the video. And the sharpness of your lead, and every time you do it, you're going to get to the closest answer. That's the one you want to pick. Remember, always circle the closest answer. So in this case here, answer number 5 would be letter C. 10:54. I'm only 3 minutes from that. So that's how you work ETA. Some of them, we're going to go in on some of them, some of the first ones. I'll explain those working on a chart. On ETA, and anytime you're working on a chart and they're telling you to run the channel or what's the length of the middle leg or York spit channel or the different things, remember, if on one of them I'm actually right here and they want to know how long will it take me to get down to here. Now, if we were flying an airplane, we would fly right from here to Trestle C. But what they want you to do is they want you to run into the channel. So if I'm here, I have to measure the distance in increments. So if I started here, which is one of the problems, I'll start here, I have to run to this channel. So that was 3.5 miles. Then I have to run down the length of this channel, which is another 4.6, 9.6 miles. Then, instead of running right straight from here to Trestle C, you've got to enter this channel. So you would run to here, and then you would enter the channel, and you would run from here to here, and then you would run from here to here. So you may have a group of 6 different distances, and you'll find that that's how the person who worked this problem, that's how they did it. They want you to stay in this channel. Same thing, there's another problem where they want you to run the York channel. You're up on the, you're up here. If you're going to run this channel, you're going to run down the length of this channel to here, then you're going to run it to here, then you're going to run it to here, and then you run it to there. You stay in the channel. So that's the ETA. You're not going to run from here to here. You're going to have a wrong ETA. If somebody's waiting for you here, you want to give them the exact ETA. So that's when you're using a channel. Make sure if the channel bends, you stay in that channel. You would come to this mark right here. This would be one measure, and then you would measure the distance from here to here. That's what they call the middle leg of York spit channel. And then you would turn and grab another one. So it's not a straight walk like we did on the other side where we started in the open ocean and we ran right to a buoy. In the Chesapeake Bay ones and some of the Long Island ones, you're going to actually have to fit into the channel. And they like these questions where they get you inside the channel, and you have to, when the channel bends, you have to bend with it. So you have to answer the question. You have to work the problem just like the person who wrote the question did. So that's how they do it. They stayed in the channel. You have to measure the channel, and it's a lot of work. You have to take a lot of little measurements and add them up. But you're going to find that you're going to be more exact, and when you start plotting, exact means everything. So that's how you work the ETA and work in the channel in Chesapeake Bay.